Hello everyone, hope you all are well. Today we are going to discuss memory organization, and the topic we will be covering is hierarchy and types. Memory hierarchy. The total memory capacity of a computer can be visualized by hierarchy of its components. The memory hierarchy system consists of all storage devices contained in a memory system, from the slow auxiliary memory to fast main memory and to smaller cache memory. Auxiliary memory excess time is generally 1,000 times that of the main memory, hence it is at the bottom of the hierarchy. The main memory occupies the central position because it is equipped to communicate directly with the CPU and with auxiliary memory devices through input/output processor. When the memory not residing in the main memory is needed by the CPU, they are both brought in from auxiliary memory. Programs not currently needed in the memory can be transferred from the main to the auxiliary memory to provide space in main memory for other programs that are currently in use. The cache memory is used to store program data which is currently being executed in the CPU. Approximate access time ratio between cache memory and main memory is about 1 to 7 to 10. Memory access methods. Each memory type is a collection of numerous memory locations. To access data from any memory, first it must be located, then the data is read from the memory location. Following are the methods to access information from memory locations. Random access. Main memories are random access memories, in which each memory location has a unique address. Using this unique address, any memory location can be reached in the same amount of time in any order. Sequential address. This method allows memory access in a sequence or in order. Direct access. In this mode, information is provided in tracks. Each track is having separate read-write head. Main memory. The memory unit that communicates directly within CPU, auxiliary memory and cache memory is called the main memory. It is the central storage unit of the computer system. It is a large and fast memory used to store data during computer operations. Main memory is made up of RAM and ROM, with RAM integrated circuit chips holding the major share. RAM, random access memory. DRAM, dynamic RAM, is made from capacitors and transistors and must be refreshed every 10 to 100 milliseconds. It is slower and cheaper than SRAM. SRAM, static RAM, has a 6-transistor circuit in each cell and retains data until powered off. NVRAM, non-volatile RAM, retains its data even when turned off. Example, flash memory. ROM, read-only memory, is non-volatile and is more like a permanent storage for information. It also stores the bootstrap loader program to load and start the operating system when the computer is turned on. PROM, programmable ROM, EPROM, erasable ROM, and EEPROM, electronically erasable ROM, are specially common used ROMs. Auxiliary memory. Devices that provide backup storage are called auxiliary memory. For example, magnetic disks and tapes are commonly used auxiliary devices. Other devices used as auxiliary memory are magnetic drums, magnetic bubble memory, and optical disks. It is not directly accessible to the CPU and is accessed using the input-output channels. Cache memory. The data or contents of the main memory that are used again and again by CPU are stored in the cache memory so that we can easily access that data in a shorter time. Whenever the CPU needs to access memory, it first checks the cache memory. If the data is not found in the cache memory, then the CPU moves to the main memory. It also transfers a block of recent data into the cache and keeps on deleting the old data in the cache to accommodate the new one. Hit ratio. The performance of cache memory is measured in terms of quantity called hit ratio. When the CPU refers to memory and finds the word cache in it, it is said to produce a hit. If the word is not found in cache, it is in main memory, then it acts as a count as a miss. The ratio of the number of hits to the total CPU references to memory is called hit ratio. Hit ratio is hit divided by hit plus miss. Associative memory. It is also known as content addressable memory. It is a memory chip in which each bit position can be compared. It is the content compared in each bit cell, which allows very fast table lookup. Since the entire chip can be compared, contents are randomly stored without considering the addressing scheme. These chips have less storage capacity than regular memory chips.